Greetings, gentle readers, fellow earthlings. Reading Foundations today from a study with Ross, Finnis, and myself. It's July 10, 2026. It's about 95 degrees outside. It's about 83 degrees inside. Turning on the air conditioning a little bit later when it really seems to kind of kick in. If it's 10 degrees hotter over 2 days, then, according to that sort of rate, then you're really about 1,000 degrees, give or take. Now, that's hyperbole, but it's something to consider with regards to global warming, as is evident, and these sorts of things. Not so relevant here. What's relevant here is foundations and reading foundations. One of the aspects and key aspects of foundations is language. So language gets its own account among the primitives or the elements of variously the heno-theories of this A theory, theatheory, geometry as point in space. Language has kind of words in space. But then there's also the expression making for the metonymy and metaphor, that which comes down from the truth, the absurd, and that which attains to the truth, the metaphor, to the absurd. Making the point that metaphor eventually fails, yet it is well, especially in accounts of the formal and the symbolic and the logical, can be very careful in what it tends to entail. Getting a box of books here and a book from the stack in the box, the Oxford paperback French-English dictionary, a dictionary of two languages, helping to identify that if you know words in one language, you can find synonyms and constructions in the other language. So language here gets a deconstructive account, kind of like arithmetic gets a deconstructive account. Like the Egyptians and Sumerians, division and partition, work it up, vis-a-vis our usual sort of didactic account with addition after the number line and multiplication after that, and those being kind of primary and being closed, the operations. And then their inverses coming back and resulting the whole complete ordered field after the rational field, one may aver. And here that's because first there are the line reals between 0 and 1, standard infinitesimals. And so that gives a reason to think that there's a complete ordered field, besides the fact that pi is irrational and transcendental, and not just irrational, like the algebraic numbers are irrational, like root 2. Roots of polynomials with integer coefficients or rational coefficients, the algebraic numbers. Having that there's a continuous domain, extent, density, completeness, measure. This comes first from the line reals here. And it has an account that basically there's an infinite element in the natural numbers. And so that it's arrived at that this line drawing is in a complement after the point in space to the spiral space filling curve, a natural continuum, that this is the way that geometry comes from point in space. Then the account of language then gets this deconstructive account as well. And it's that we're kind of in the middle of it. With arithmetic, we kind of start at one end or the other, and then it's always kind of both ends, 0 and infinity here, or from negative infinity to infinity. And then we start, whether we start in the middle or start at the beginning, there's just kind of a count that a point is the first point on a path in a beginning. So words kind of live in the middle of the context, the meso-scale, the medi-mal of this sort of account. So to get a deconstructive account is that what we're talking about, the words, is like nouns and verbs. So grammar here is getting a deconstructive account that really those are kind of the end result, the verbs of infinitives themselves. So usually the infinitive is given later. It's like, an infinitive is a count of something that happens for a verb. To reflect a reference to to other copulas and verbs where copula is kind of a weak yet omnipresent sort of verb, to be, the existence, the existential and intentional equivalence in these sorts of accounts, the copula. And then the verb has that the infinitive is actually a thing. So in thinking about conjugating verbs, then the idea that the perfect sense is never really addressed. It's kind of the statement as it is and as it goes. These are the imperfect in the past imperfect in this sort of account. So the deconstructive account of language includes both metaphor and metonymy as accounts of the expressions, and then for the words and the elements of the natural languages, that these are kind of present in all the natural languages, and it's not really called out that it's kind of the infinity of the infinitive, and it's kind of as like it's what's arrived at, the verb, and then vis-a-vis nouns as objects, and those as reference and relata, vis-a-vis the anaphora and cataphora, usual accounts of relaying and relating things, for metaphor in these sorts of accounts. So a bit about language. Then there's some more about language here in this box of books. What's this say? Oxford Grammar of Classical Greek. So I haven't really studied this book at all. I studied French in school for 3 or 4 years. That was the elective. Everyone had to take a language as an elective, a foreign language, from English. And so it says, for example, contracted verbs. So it's verb conjugations, the indicative, imperative, subjunctive, and optative. The middle of the passive, the active. For the future aorist and perfect, contracted verbs lengthen their vowel before the ending, with O becoming omega. Forms of the first person singular in these tenses are, for the future aorist and perfect, the active, middle, and passive. So perfect passive vis-a-vis perfect active. This makes a nice little grid of the ways to look at these things. Note that the present infinitive active of these verbs ends in -iv. The tau of the regular infinitive ending -iv, originally -iv, is not found in contracted verbs. So this gets a little bit more into examples of the conjugation and the cases and the ways these are for the passive, the future, the aorist, the perfect, and pluperfect are as follows. And then in Greek, I yet don't have much phonetic access to the Greek alphabet. As with all verbs, and then a dictionary, copulas and to send, to fill, to act, to sell, to break, to send, to save, to cut, to place, to beget, these sorts of accounts. That this would be useful if someone's going to study the classics in the original tongues. Here's question words. So here, question words is another great account, or interrogatives. What, when, why, how, when, where, and so on. Then has that there's what and what is besides the interrogative, it's also the direct object that makes for usual explanations, answering questions posed or implicit. So interrogatives, and whether interrogatives or statements are first in the language, kind of has it varies. So again, interrogatives and statements also have their sorts of accounts of being complementary duals. Main trends in the science of language. Roman Jacobson, from Harper Torch Books. Originally $4.95, $8 from the Globe Bookstore. I have a number of bookmarks here from the Globe Bookstore. This is where I got this little bookshelf. When the Globe Bookstore during COVID, they were going out of business, and the proprietor was selling some of the stock, including the shelves. I got the shelf. He just retreated to his bookstore in across town. He had 2 bookstores, so the Globe Bookstore was still a thing. It was just that one. Main trends in the science of language. Part of this volume appeared in an earlier version as Chapter 6 in Main Trends of Research in the Social and Human Sciences. Part 1, Moot and UNESCO, 1970. Book was also published in Great Britain in 1973 by George Allen and Unwin Limited. Stéphane Mallarmé in 1869 says, La science ayant dans le langage trouvé une confirmation d'elle-même doit maintenant devenir une confirmation du language. The science is having in the language found a confirmation itself, must maintain that it comes of itself a confirmation of language. And so that's just usually an account of the interrelatable. And so the interrelatable after what must make the intersubjective. Why language is the account or for the textual of what that is. Is music a language? It's an expression. I imagine there are ways to consider it as language. It's lyrical. It has lyrics as the textual. And otherwise, it's kind of a little bit less than language. That said, music sometimes is given as accounts of the physics of things. For example, Johannes Kepler's Harmonische Mundi, the harmony of the spheres, or the harmony of the worlds. So whether music as a language is its own sort of account. And then whether superstrings, for example, are supposedly, according alike to being the strings of a musical instrument. And then whether science had its first account of having reproducibility by defining a stringed instrument by its dimensions and thus resulting a sound that was repeatable, or pipes and drums is the idea usually preceded that. Jacques Monod in 1969 wrote, I believe that as the scope of science broadens further and with increasing speed, confrontations between disciplines become more than ever necessary. That's so and not so. The idea of foundations is that there is a discipline of foundations, and then everything else is given its own account for whatever else it actually has its empirical milieu. Contents in Linguistic Vistas, the place of linguistics among the sciences of man, linguistics and natural sciences. So taking a look at page 25, where it begins chapter 2. The autonomy of linguistics was the catchword launched and propagated by Antoine Meillet at the First Congress of Linguists, Hague, 1928. And then the concluding report of its secretary, the noted Dutch linguist J. Schrijnen, with reference to Meillet's standpoint, viewed the entire historic assembly as a solemn act of emancipation. Quote, it was a tentative trial. Linguistics pleaded its own cause in full daylight and before a universal assembly. This was a pertinent and timely program, which throughout the subsequent decades deepened and enhanced the methods and tasks of our science. At present, however, we are faced with an urgent need for an interdisciplinary teamwork to be pursued diligently by savants of different branches. In particular, the relationship between linguistics and the adjacent sciences awaits an intensive examination. So for linguistics and natural language, there's the ACL Anthology. It's a website, so www.aclanthology.org. It's got, from all these many conferences in natural language understanding, according to programmatic and formal accounts, it's got a large backlog of thousands and thousands of research papers in the science of that, and so and the theory of that, and the prior art and all these sorts of things. So then the kind of linguistics as a science has that it's a theory first, and then there's a science of the theory. The necessity to combine the internal consolidation of linguistics with a substantial widening of its horizon was enunciated by Edward Sapir shortly after the Hague Congress, and most probably as an immediate lucid response to the latter's platform. Here that linguists, whether they like it or not, must become increasingly concerned with the many anthropological, sociological, and psychological problems which invade the field of language, because, quote continuing, it is difficult for a modern linguist to confine himself to his traditional subject matter, unless he is somewhat unimaginative, cannot but share in some or all the mutual interests which link linguistics with anthropology and the history of culture, with sociology, with psychology, with philosophy, and more remotely with physics and physiology. So here the kind of words and language is kind of just for philosophy's sake. And so linguistics itself, for example, from something like Watmo's theory of language, and the accounts as of like Hoope and Kaminsky, logic and language, and the phonetic accounts, and relating that to phonemes and their utterances, or otherwise sounds, notes and tones included in the harmonious, I guess one might put it, vis-a-vis the language of language, or the language of linguistics, and the language of music, has that the account of language and linguistics as its own kind of science, and from a formal account is after words. Here is that those are just efforts and acts and interpretation of words. And so here, for the foundation's sake, there's words, and then what those are, what those mean, and all the accounts of semiotics after syntax and semantics. Those are just usual in the usual account of then the study and in the richness and depthness of different accounts and meanings, and the evolution of language and these sorts of things are their own kinds of ideas. As a question of what communication is, and all these sorts of accounts, linguistics is a very broad field, and very multidisciplinary or cross-disciplinary itself, yes. Recently, the interdisciplinary rally of the law-seeking nomothetic, or according to the terminology of Peirce, nomological sciences of man, whether labeled social sciences or humanities, or the soft sciences, as they're put sometimes, has been brought forward by the panel of consultants drawn together by the Department of Social Sciences at UNESCO in connection with preparation of the present volume on the new trends of research, social and human sciences, the modalities of such a cooperation, underwent a stimulating discussion. So this just gives an idea of kind of the account of these colloquia. In contradistinction to all other sciences of man and to some natural sciences of relatively recent modern origin, the study of language belongs to the few earliest branches of knowledge. A keen outline of Sumerian, the most archaic among the extant grammatical writings, is separated from us by almost 4,000 years. Both linguistic theory and empirical research have displayed a varied and continuous tradition from ancient India and Greece through the momentous achievements of the Middle Ages, the Renaissance, the area of rationalism and Enlightenment, and finally the manifold scholarly trends of the last 2 centuries. So the first grammarian, historically, is perhaps India's Panini, or Panini. I'm not quite sure how to pronounce his name. And while it's is a sort of a simple account today compared to something like Kerm's grammar or the Cambridge grammar of the English language, Kerm's being a grammar of the English language that I've studied, has that it's grammar and well-formedness and syntax in these sorts of accounts, vis-a-vis style, or any other accounts of the evolution of language, which it's a living language. Vis-a-vis, when they call a language a dead language, they mean that they're not adding any new words, they're not adding any new meanings, except what you might interpret. The dictionary is closed. It's a dead language, yet alive in the sense that it still has all its statements. And so Sanskrit has never been a dead language, and Latin not much either, because the loan words in the Indo-European languages, the family languages, and then to today's like English, and it's significant and even large Latin and Greek influences, have that's today. The lingua angla, as it's called here, is what used to be the lingua franca, kind of the patois of international commerce. There's basic British and American scientific, industrial, and commercial basic English. The internal logic inherent in the sciences of man, in turn, demands their serial arrangement paralleling the linkage and concatenation of the natural sciences. Language as one of the science systems and linguistics as a science of verbal science is but a part of semiotic, the general science of signs, which is foreseen, named, and delineated in John Locke's essay, or the doctrine of signs, the most usual way of being words. Coserio cites J. de Sao Thomas as a predecessor of Locke in the field of semiotic, where he proves to be closely linked to the scholastic tradition. One finds an echo of Locke's thought and nomenclature, semiotique, in the philosophy of language of the Pole, Hoyni-Wronski, at the beginning of the 19th century. Charles Sanders Peirce, or Charles Saunders Peirce, sometimes I've seen it, convinced that many passages of the essay concerning humane understanding make the first steps in profound analyses which are not further developed, took over Locke's term semiotic, which he redefined as the doctrine of signs. This pioneer and backwoodsman in the work of clearing and opening up the new discipline issued the first of his numerous attempts at a classification of signs in 1867 and devoted a lifelong study to the doctrine of the essential nature and fundamental varieties of possible semiosis. So poesis, mathesis, making lyrics, making mathematical forms, semiosis, making a meaning of things, and an account, first class and a conscious account. Theoria, making theory, these sorts of things. Since his drafts of the 90s, where the name semiotic was first introduced for the new branch of knowledge, were published only in the posthumous edition of Peirce's Legacy, they could hardly have been known to Ferdinand de Saussure, when, like his American precursor, the Swiss linguist in turn conceived the need for a general science of signs, which he tentatively labeled semiology, and which he considered indispensable for the interpretation of language and all their systems of signs and their interrelation with the language. Since it does not yet exist, one cannot say what it will be, but as a right to existence, its place is determined in advance. Linguistics is only a part of this general science. The linguistic problem is first and foremost semiological. Thus, not only will one illuminate the problem of linguistics, but we think that in considering rites, customs, etc. as signs, these facts will appear in a different light, and one will feel the need to arrange them in semiology and to explain them by the laws of that science. So this goes on to carry in that a little bit more about the idea of the semiotics. Here I really think there's much of the book of Umberto Eco, A Theory of Semiotics. And so that's really a pretty great work. And so I even think that eclipses his fiction. I don't know anything else he's written technically, Eco, but A Theory of Semiotics is really quite great. About reference and relata, here the signans and the signatum are reference and relata, usually enough. So this gets into the idea that any utterance is has more than one translation. And then it has all the different relations and all the different connections to all the different contexts in the world. And so then that obviously those are more proximate and they have more affinity to very regular and usual context, or the commonsensical or the direct still has its own kind of thing. Then the author gets in talking about economics and relating communication to economics, and then ideas of what the signs and meaning, and the variable radius of communication, the problem of contact between the communicants, communication and transportation, vis-a-vis the interrelatable and the interrelatable for the intersubjective here, psychological issues, accounts, social modeling, linguistics and the natural sciences, emphasis, the auditory and visual stimuli, research, talking about the psychological again, puns, dreams, and troubles of language as diverse forms of a mental diplopia may be cited among as many ideas which were ahead of those times. Jackson. Luria, corroborated by observations of other contemporary neurobiologists. A keener insight in the biological foundations of language may be expected from the ongoing process or experience with split brain operations. Further progress of comparative inquiry into aphasia on the one hand, into agraphia and alexia on the other, must throw new light on the interrelation between spoken and written language. While general semiotics will benefit from a parallel research in language disorders and other forms of asymasia, such as amusia or disturbances of gestual systems. Acoustics. Acoustics is the only branch of physics that shares a common subject matter with the science of language. Now, this is arguably not so because the weight of words has their information content, and that gives, just like a simple machine has mechanical advantage, then a simple amount and account of information gives the information advantage. with regards then to the reasoners and their ability to have it so that language then is basically the transport of information in that sense, does have a physical meaning besides just acoustics and the study of the phonemes and the phonology. A slim volume of 75 pages, yet very dense, and a survey with hundreds and hundreds of bibliographic resources. Jacobson's main trends in the science of language is evident today, and these same source counts that being the dogma of linguistics, the science. This book is a biography. It's David Sobel's Galileo's Daughter. So Galileo's Daughter is about the writings between Galileo Galilei, and his daughter, I forget her name, and who is constant during the times of Galileo's house arrest, during the accounts of the Inquisition and Urban VIII and the Reformation of Martin Luther, the corresponding Counter-Reformation of the Catholic Church, René Descartes, hundreds and hundreds of miles or leagues north, in the same sorts of tradition, opening up these sorts of accounts, that the Reformation had it so that Luther, while at the same time rejecting the papacy and making for his account of his dogma and religion that it was according to his manifesto, and these sorts of things, the Reformation, Protestant Reformation. And then the Counter-Reformation had also aspects of it that were like that Luther rejected scholasticism. And so he made for like the Calvinists and these sorts of things at the same time, and that part of the account that given to Galileo is like he was persecuted by the Inquisition. They're anti-science. And that's not really the case. And then the play and the theater of his thing here, as we read here from like The Crime of Galileo, which is a pretty good book from Time Life Books back in the 50s or 60s, decades, even 40 or 50 years before this book here, has that it's a theater bit. And so, and then Galileo has the Galilean laws of motion and Galilean invariance. And that follows the Mertonian school and latitude of forms about 100 years before that. It's about the same time as Cavalier's Indivisibles. It's about the same time as Descartes and a lot of stuff going on that Descartes could give a lot of the account of the theory. The Galileo Galilei's theory was a simplification, and then it kind of survived and carried forward as Newton's simplification, the reductionism here. And so there's room in the theory for more than Galilean invariance, because Galileo basically never studied spinning bodies. And there's the account that when angular momentum is considered to be conserved and linear momentum is considered to be conserved, it's as well that as soon as there's all the kinematics and dynamics, it's lost because of the interplay and interchange between the real and the fictitious. This is called hundreds of years later by the likes of Lagrange after Maupertuis and these sorts of accounts. So when looking at something like Leibniz and the Newton affair, where the idea was continuing as after Galileo got enshrined and the immense popularity of his work so followed, and then Newton had the system of the world. So after Kepler had a system of the world and explained how everything was moving, then Newton gave a formula and just set its inverse square and gave solutions and formulas to give things. Kind of like Kepler had solved the system of the world, but the calculus made it possible to give the numbers quicker. Where for Kepler he was just still solving a three-body problem or something like that, which is difficult compared to the account of inverse square that Kepler gives. So the law of universal gravitational acceleration was kind of given by Kepler already. And then the accounts of the Galilean invariance was all kind of given by the Mertonian school already. And then for Leibniz and Newton and the Descartes, who they follow and study, and then Clarke, a correspondent with Leibniz, they had a great debate about the vis-motrix or vis-motrix. I'll say v-motrix, like vis-a-vis. It's soft when not followed by a vowel or silent. The s. V-motrix, vis-viva, and vis-insita has it that these different accounts kind of relate to Newton and Leibniz and Descartes. And so then when talking about mechanics and motion and these sorts of things, it's so that there's room in the theory to have about why that's the linear account starts to fade and fail as soon as there's motion, more dynamically considered all the unlinear, as from like moment in motion. The series here just kind of arrives at that, studying all the definitions and formalisms of mechanics and then what it means and why for Lagrange to arrive at basically the Lagrangian mechanics that basically give us the Hamiltonian that these days is used to solve the Galilean invariance most usually, and then secondarily later to solve the relativistic invariance, or for the quantum mechanical, as is also considered here in earlier accounts, about the Lorentzians and then the Schrödingerians vis-a-vis the Galileans, and that being linear according to Descartes in large sense. So the Newton and Leibniz, their affair, and their kind of the priority dispute also includes things that are controversies. Because it's not like, well, we invented a calculus that's the same, which one of us did it first? Priority dispute. It's also is like, well, what does it mean and how does it get there? And then for other counts of relations to other things, like that space is relational. And like here, the doubly objective relativity theory was like, well, motion is relative. Well, that's the usual enough thing since Galileo too. Well, it's like since Leibniz, also space is relative. And so the doubly objective relativity theory is just as simple as that in a sense. And you can read from Leibniz a great constructive development and defense of the relational theory and relativity, those being not much different. So that said, it's Galileo's Daughter is a touching account of their lives and after their communications, historical memoir of science, faith, and love. Talking about the events and all her appeals to try and get them released and all this kind of stuff. So yeah, the book The Crime of Galileo is a better sort of account, I would suggest, if wanting to understand what Galileo means. This was a very popular book a decade or so ago. Gaston Bachelard, The Poetics of Space, from Penguin Classics. Foreword by Mark Z. Danilewski. Introduction by Richard Kearney. Since its initial publication in 1958, The Poetics of Space has been amused to philosophers, architects, writers, psychologists, critics, and readers alike. This lyrical journey takes as its premise the emergence of the poetic image and finds an ideal metaphor in the intimate spaces of our homes. Guiding us through a stream of meditations on poetry, art, and the blooming of consciousness itself, Bachelard examines the domestic places that shape and hold our dreams and memories. And then it quotes Michel Foucault. Now, I'm kind of troubled by Michel Foucault. And now there's Foucault de Foucault's pendulum. That's a famous, important scientist, like harkening back to the times of the 17th, 18th, and 19th century. Foucault. But Foucault, the 20th century philosopher, is kind of off the deep end. It's something. It's not a technical approach, and so that's part of like the Marxists and stuff like that, and those sorts. So that's political and social. But otherwise, poesis and accounts of language, of course, are these sorts of things. Talking about Baudelaire and Taine. I haven't heard of Taine before. A Max Picard. Of course, in describing a phenomenology of the man with a magnifying glass, I was not thinking of the laboratory worker. A scientific worker has a discipline of objectivity that precludes all daydreams of the imagination. Oh, I would disagree. He has already seen what he observes in the microscope, and paradoxically, one might say that he never sees anything for the first time. An opposite interpretation could be true. So this is kind of an account of a deconstructive account in the postmodern, and then the account of that is like to give it another one, and then how it's structuralist realism, and that's science. Rational mechanics. Let's see if there's some bit more about linguistics here on the top of the stack. Quantum theory of collective phenomena. About the same, kind of the same form factor. Same publisher. Dover reprints, a wonderful mark that has kept unknown many important scientific works in print. Dover reprints. Polyelectrolytes. So this would be electrolytes are in solution. This is Technomic Publishing, 1976. Serlin ionomer resins, polyelectrolyte complexes for medical applications, the grafting of polyelectrolytes. Serlin ionomer resins, electrocellular microbial polysaccharide polyelectrolytes, properties and applications, effect of polyelectrolytes and the rate of ionic reactions. Perhaps something to look at for a moment. Fourier series and orthogonal functions. This will go with the next to the differential analysis and the integral analysis. The Fourier-style analysis is its own sort of account. Kind of like the convolutive setting, it has bounds, and so then it intends to describe what can be made from those. So you got Fourier-style analysis, there's Bessel functions, the many shape and scale and other parameters of Bessel functions, and how those add up together. Here there's, after Fourier series being trigonometric, then there's the trilateralometry and the n-lateralometry or n-gonometry. These accounts of like, well, you know how you take a right triangle and so if you draw a circle and just connect the right triangle, and it gives sine and cosine according to the ratio as Pythagoras gave us of the equal and opposite, or the opposite and adjacent cosine and sine vis-a-vis the tangent. Opposite over the tangent being the cosine, and adjacent over the tangent being the sine, and opposite over adjacent being the tangent. Yeah, all right. So, you can take an equilateral triangle and just unhinge that and just spin it around and just kind of swing it around, and it also draws a sine curve. So it does. It has another way to look at that. It's like, okay, well, yeah, so what? It's like, well, you know that if you have a circle, you can draw a triangle in it, and then you can get that kind of trigonometric functions, okay? So do it for, instead of a triangle, do it for a square. It's like, well, that pretty much just gives me two triangles symmetric about the thing, the one above and one below, kind of whatever the radius is, right? Well, what you do instead, now that you know that you can unhinge an equilateral triangle and then swing it around so all the angles evolve at the same rate, and then just kind of, as it unrolls and rolls over, it flips around and maintains its a progression as like a periodicity, say, that draws the sine wave or the cosine out of phase. Now, you can do that with a square or any other regular polygon or any other polygon at all, and it will draw some kind of function. So this whole entire family of functions is right after the trigonometric for the n-lateralometry or n-gonometry, n being arbitrarily many, polygonometry, and these sorts of accounts, that then Fourier series and orthogonal functions end up making for that cosine and sine are the orthogonal functions in Fourier transforms. But this book might give an account of other accounts of orthogonal functions, which basically have that, well, their integral of their product is 1, except in one place where it's 0 when they're equal, or vice versa, that it's the opposite of that. And I'll feel bad because I think I'd said that reversed, that it's 1 when they're equal and 0 when they're not. But again, a non-standard product, because then to have any analytical character at all, it's built into the Feher sums and for César's summability, but in the Feher sums and the Dirichlet kernel, in the Fourier kernel to make Fourier-style analysis as it's usually given. So that said, there are a lot of other ways to make infinite series, and then there are also a bunch of different other ways to make orthogonal functions for all these kinds of Fourier-style analysis. So Fourier-style analysis is usually given as a superclassical result itself. After, like, Zeno's accounts are superclassical. The calculus, superclassical. Fourier-style analysis, superclassical. Quasi-invariant measure theory, doubling measure and doubling spaces, superclassical. They have their own sorts of developments necessary to put them together. And so the Fourier's analysis has a bunch of other kinds of analysis and the transforms. And then using that to use functional analysis is very common and applied in many, many settings. Art Access, a flyer. Michio Kaku, The God Equation, a quest for a theory of everything. But for some reason, the symmetry of the Higgs field began to break. So by the 1970s, the hard work of scores of physicists began to pay off. So today we know that the Higgs boson is a divot. And so it has two particles. It's not just one particle anymore. So closing the standard model by no means ended the search for new physics. And anybody who's got a field theory and it's like, well, we just removed one of the old fields and now just added the Higgs field. They have just truncated and made a three-legged dog about what supersymmetric relations in field theory are supposed to be. Not that there's anything wrong with a three-legged dog. A three-legged dog is one of the most responsible and loyal animals. Fromm and Taubman, policy simulations with an econometric model. So this is for this study in this science of economics, the econometric. So kind of like your hard MBA is kind of the idea. The quantitative and all this sorts of account. So this is about policy objectives and econometric models. So it's kind of like game theory and just like matters of communication for the economy and this sort of stuff. Brookings' econometric model, condensed system of equations and list of variables and definitions. Sector subscripts. Agriculture, forestry and fisheries, farming, contract construction, non-farm business, federal government, government enterprises, federal government, state and local government, manufacturing, durable manufacturing, non-durable manufacturing, residual industries, mining, finance, insurance, and real estate and services, mining, wholesale and retail, services, finance, and contract construction. All industries except manufacturing, wholesale and retail trade, and farming, wholesale and retail trade, and contract construction, plus residual industries, mining, finance, insurance, and real estate and services. Regulated industries, railroad and non-rail transportation, communications and public utilities, wholesale and retail trade. These are considered the real economy. The value, vis-a-vis the spend, these sorts of things. J.R. Carnes, Axiomatics and Dogmatics. So axiomatics are theories, just given axioms. These are their rules. Dogmatics, as I could only so imagine, as of the dogma. And so it's what sort of intuitionist accounts guide then other accounts of axiomatics. And that there are certain axiom systems that are dogmatic themselves. And then there's some canon, and what it contains is said to be dogmatic, the dogma. And so it's kind of like they said about the central dogma of molecular biology, that all actions of biological cellular reproduction are due DNA. And so that's the central dogma of molecular biology. And then later it's like, and there are environmental factors explaining why the differentiation of stem cells, the progenitors of other cell lines, make us of the totipotent, the pluripotent, and the multipotent stem cells. There's specialization, the way how they become different parts of the body. That the central dogma has a new central dogma, or it was there all along, or something like that. So that said, it's kind of like the account for mathematics and so on. It's like, well, we have a set theory, that's a dogma, and then when you think that, oh well, an ordering theory is also a theory of one relation, why not? Is just as fundamental, or like a set class distinction occurs. Do you have a theory with both of those or not? So these are aspects of dogmatics and axiomatics. Criteriology, a meta-theoretical discourse. It mentions Bungay, so this is physics, and these are philosophers in physics. The success of a realist interpretation of the received view may now appear to have been a Pyrrhic victory. There may be a real world out there for science to explain, but the nature of that real world is shaped by the very theories we hope to confirm or disconfirm by our observations of the world. And that kind of is so and not so. That a theory is just self-confirming itself. And so here it might be talking about quantum mechanics or something like that. The confidence of it, hard-nosed realism, would seem to have given way to a kind of subjective relativism. The world is whatever it appears to be as seen through the particular spectacles behind someone's eyes. Here instead it's just that science has a tremendous role to fulfill, and it's never being wrong. And if it ever changes, we were wrong, not it was wrong. So it's not right until it's done. And so that's a structural realism, or hard-nosed realism, or the extreme rationalism, also it's called here, as Hilbert and company put it when reading from Mancuso at those. So axiomatics and dogmatics. Then he gets into like religion and theology and these sorts of accounts. The uniqueness of theology, truth claims in theology, meta-theology and meta-science. Then he brings in like William James in this, so I kind of tuned out at that point. And so this has interesting discussion about relations of what's given to the theological. Here that's just like a briefer, mere teleology, not necessarily theology. And so the teleology is a necessary thing to have. Otherwise, that logicist positivism is lost without some ideals. And if it admits that there's ideals, now it has them. What it has is science, and then for the real objects though of mathematics, the Platonic ideals, the strong mathematical Platonism, has that's a teleology for the ontology, the giant word base of the knowledge base of all the things that it's supposed to be that science understands to keep track of vis-a-vis what it can never confirm, only yet among all its theories with what it's given as knowns deny. Theory of science, and similarly for the statistical hypothesis. Introduction to molecular pharmacology. So the development of and understanding, the study and research of medicine, pharmacology, the study of drugs, or that. This has molecular pharmacology as from Holland, Klein, and Briggs. It's talking about molecular structure and chemical bonding, structure of macromolecular systems. So this is the structural chemistry. It's above the atomic chemistry. It was just called organic chemistry. So you got inorganic chemistry, which is everybody's happy-go-lucky tinker toy model of chemistry is atoms. And then the structural chemistry, after like Brandon Speakman and organic chemistry, is the resonance theory above the fixed length bonds of fixed angles too. So these are the things. The structure of cells, talking about cells, a ribosome, a cytoplasm pore with an annulus, a diaphragm, unit membranes, the nucleoplasm, or the cell walls, the cell rafts, and the transport vesicles. Development of intercalated disc. Chemomorphic basis of molecular pharmacology. So that's about how drugs get in and out of cells. Thermodynamics and the concept of free energy. So giving for accounts of rates of reaction and these sorts of things. Metabolic pathways. Schema of glycolysis, for example. The oxidation of 3-phosphoryl-D-glyceraldehyde. The oxidation of 3-phosphoryl-D-glyceraldehyde, formed by the cleavage of fructose 1,6-diphosphate, was established by Warburg and Christian, 1939. This is an extremely important reaction, for it illustrates these chemical events associated with the rearrangement of bond energy of the original substrate glucose and how it's transferred and conserved in energy-rich compounds, ATP. So that's like the opposite of entropy is what's going on there. Free energy utilization. Myosin. This book covers a lot of interesting sort of surface elements related to what is related to metabolic pathways and respiration of the human body, mechanisms of drug action, and an extended bibliography. Olfaction, about aromatherapy and the like. Stable chaos, an introduction to statistical control. So it's not quite statistics. It's control theory or prediction theory. So it's got knowns and tosses them together with the unknowns, and then uses the methods of probability theory to then start pulling things out and then say those predictions. So not so. Then it's got an integral formula and a convolutive setting. It's like g of x times h of s minus x. So the convolutive, as they come together, the integral of those as they cross, and then the idea is these are orthogonal functions. When they cross, there's a bump. And so that's what the orthogonal functions are with regards to the convolutive setting, Fourier-style transforms. And here, this is independent variables to convolution. It's convolution in the distribution of a sum. So it is convolution. Variance of a sum. Extension to higher moments. So this is something I should read. This is a higher book in probability theory and statistics as well. David Durand, D-U-R-A-N-D, Durand. W.S. DiPiero, Memory and Enthusiasm, Essays, 1975 to 1985. This is a philosopher of sort. DiPiero's essays are similar to Susan Sontag's, in that both writers attempt to instruct a broad segment of the American reading public about conceptual systems that challenge and enrich our ordinary ways of understanding social reality. DiPiero writes in the genre of the essay for the same kinds of reasons as Sontag, with the same cosmopolitan leaning and the same brilliant intensity, from Emily Groschholz, Pennsylvania State. Draws us towards fresh encounters with literary artists from both sides of the Atlantic: Dante, Keats, Leopardi, Whitman, Pound, William Carlos Williams, Pavese, Sartre, William and Henry James, and others, and as well with filmmakers. The Jahn-Teller effect, J-A-H-N, Jahn-Teller effect in C60, carbon 60, and other icosahedral complexes with C.C. Chansey and M.C.M. O'Brien. So these are carbon forms of the buckyballs, sometimes they're put. C60, the shape of the distorted molecule. And so after accounts of structural chemistry, giving angles and systems of equations, the method of Upik and Price, O-umlaut-P-I-K, and Price, P-R-Y-C-E. First thing to do to characterize these surfaces is to find the minima and other stationary points of the APES. So this is a lot about the the mechanics of buckyballs, I guess you might put it. The n-mode cluster Hamiltonian. The next question to be addressed is whether this cluster approximation gets worse if the number of coupled modes increases. So building methods and reductionisms and approximations. Accounts of order and some tables at the beginning, the first few of these initial segments. Character table D.1. In the table R equals 1 plus the square root of 5 or 2. R is the golden ratio, satisfying the equation R squared equals R plus 1. And then it gives, from Dresselhaus and Eklund, the group I. So that's something to check out is Dresselhaus and Eklund. Dresselsselhaus. And Eklund, Eklund. And then the next appendix is Jahn-Teller interaction matrices and their bases. So these then are part for group theory up above, kind of the analytic part and how that's arrived at. What gives the expressions later. Perfectly reasonable deviations from the beaten track. The letters of Richard P. Feynman, edited with an introduction by Michelle Feynman, forward by Timothy Ferris. Letters. Human blood coagulation. The Boerhaave series, Boerhaave, Boerhaave series. So this is under medicine as well. Human blood coagulation. So you got platelets, you got S and C proteins, you got various sorts of accounts to figure out with regards to platelets. Blood coagulation, fibrin, fibrinolysis, for example, that's blood thinning. There's a Kinnan-like activity that is simultaneously produced. I would like to propose an alternative pathway for the generation of this kind of tissue toxin. This is derived from results obtained in complement studies from Pondman. So given in accounts that among the metabolic pathways, then there are accounts of the beyond homeostasis, which is like it kind of stays in the middle. Blood flows, yet it's not too thin, it's not too thick, it's just right. Homeostasis. And then a lot of different metabolic pathways affect that. And so just like in the immune system, there's cascades and all these kinds of things, that there's feedback. There's always feedback involved. And so similarly, that's always the intergrow differ and differ intergrow in the systems that would sort of find these things by related rates of compounds, for example, and their metabolism and respiration and these sorts of things. Medieval number symbolism. As you can tell, this box is seems kind of half medical and chemical, and then half semiotics and these sorts of accounts. But this book is called Medieval Number Symbolism, and what it's about is kind of like what did the medieval types write about, how they thought about numbers. Although such works as these indicate the attempted definition of a number science, they do not indicate the popularity which symbolic numbers enjoyed in the Middle Ages. Actually, no branch of medieval thought appears entirely to have escaped the influence of number symbolism. Just kind of a history. It's got a man with an abacus or an alike account of a table, and then a man with symbolic forearms in algebra. Seeing who's computing. Well, we're just kind of running out the hour here, is the sense. The Philosophy of Leibniz, Metaphysics and Language by Benson Mates. This from reading Leibniz last episode, and about the after Kant and the prolegomena to any future metaphysics, then there was the Leibniz, and then discourses, and then the monadology. So the discourses is again part of this account of Leibniz and Newton, and Descartes, and then Clarke kind of on the side of motion and its account. And so here is kind of described that, for example, Kepler gave Newton a lot for the universal law of gravitation, and Galileo gave Newton a lot for the linear. And then where Newton got the analysis, the calculus, the idea is usually that he came up with that. Then there's that's so following stuff like Cavalari's infinitesimals from Galileo, or the developments of the analysis by Maclaurin, and a bunch of these different kinds of things. There was a fractious time there. This book, though, about Leibniz and the philosophy of Leibniz, metaphysics and language, that kind of closes this essay today, which started with a talk about language, and then getting back from the metaphysics and the physics and the metaphysics and the language. Because Leibniz also had a kind of a universal language, a universal grammar. Here is kind of expressed in the Comenius language, the language of all the truth in the universe that nobody can hear but somehow plays through everything. The Comenius language, the universal grammars, then being all the relations of those. Leibniz's account of language, and then having one of those for the ontology as well. It's like, and so now also every utterance in a natural language also lives in this structure. So we can discover what that is, or at least discover an account of what that would be, like by postmodern deconstructive account and a reconstructive again later account. More again later. Good day, gentle readers. Stay cool.